So the first law in this order would be, this is what we stated that day. If I have log AY is equal to X, this implies that Y is equal to A to the power X. This must be kept. The second one, if I have log A1, I should get 0. And you can see from this one is just an application of this guy. A to the power 0 is 1. So you must have that. And then third, if you have log 10 y, this should be taken as just log y. 4, if you have log e y, we just take this as ln y. And then 5, change of base. Change of base. If you want to move, change of base from base A to base B. So if I have log A y and I want to move to base B, it's going to be log B y over log B A. Very, very critical. Then 6, if you have log A x plus log A y, this will be the same as log A x multiplied by y. This works in either direction. 7, if I have log ax minus log ay, this can be written as log a x over y. And 8, if you have a log b x, you must know that this is the same as, or let me start it in this way, in reverse. If I have log a x to the power b, it is the same as dropping the power b and have log a x. Like that. What else have we left out? Now 9, if I have log a negative x, this guy is defined for all x less than 0. So that the other one will be defined for all x greater than 0. So that log a0 is undefined. That's simple. And then I bring in, so let's say, and exponentials there. So that now we bring in some of the exponentials. if you know you have a to the power mn, this is the same as am to the power n. It's also the same as an to the power m. Those are indices. 13, if I have a, m plus n, it will be the same as am multiplied by an. And if I have am minus n, it's the same as am divided by an. And if I have ab to the power m, it's the same as having am b m. What else? Now 16. If I have log a, I'll get 1. Seventeen. If I have log a to the power b y, it's the same as having 1 over b log a y. This one will check. Put a star for now. I need to confirm. Okay. So I can look at examples now based on these properties.
Sir, please
Sir,
don't change your voice.
Finish writing.
Hello? Or I should wait for you to finish writing?
Yes.
Yes, sir.
Okay. But don't forget these. They're very, very important.
So as we are finishing writing, repeat on number 5.
So to change the base, you fix the new base for y. It becomes also the base for what was the base in the denominator. So you'll see, you understand them better when we do examples.
So then 8.
8, you were just saying that any power can be dropped from its position to becoming a coefficient of log. It doesn't matter. If I can add another one, 2 to the power a is not equal to 0 for all values of a.
So then number 17.
For all values of a. 19. I also want to say that 2 to the power a is never is greater or equal to 0. It's never 0. I said it's never 0 on top. So 2 to the power a is always greater than 0 for all values of a. Number 17, I said, we put a star, we'll confirm in our example.
Sam,
Uh-huh.
Sam, excuse me.
Hello.
Sam. So I have a question.
Please ask.
That one where you're saying log A, and then in brackets negative x, then you're saying defined for OX,
Less than
for
0.
OX is less than 0.
Yes.
Yes. There's a situation where you have a negative log.
That's why I want the x to be negative so it can take away that negative, which is there.
Oh, all right.
Mhm.
Okay, I understand. Thank you.
We can do examples now.
Yeah.
Wait, sir, just a minute.
Excuse me, sir.
Okay.
Would you please explain number 17?
Okay. So I want to explain number 17 using an example so that we see if it will work. I'm not so sure.
Okay, sir. All right. Okay.
Very, very nice. This page is very, very nice. If you don't forget this page, you are done with logarithms and exponentials. As long as we are at UNZA. Have you seen that property? Law number 1 sketches all the logs and exponentials. Because it allows you to move from logs to exponentials. And then you know the family of exponents. You also know the family of logs anyway. You know when y is a variable, you know what happens. When x is a variable, you know what happens. So it's all good news. Good news, good news, good news. And 18 and 19 are just there to remind us of the thing that you have seen before. Okay, let's go to another page now. Examples. So 1, change the base. Change the following bases to the stated ones. A from base 3. We'll just be saying A to base 3. Log 7 fifth. Solution. A log 2 9. We change it to base 3. We'll say log 3 over log 3. Knowing that with 9, later we take to the previous base. And then
So what would be right?
Let's say the or the outside for A of where over log satisfy this squared. And then the property tells us to drop the power 2 and leave the log at the power. That's how we dropped the 2 from being power to being the coefficient. And then we also have the property number 16. It tells us that if I have log AA, I'll get 1. So we have log 3. So that is 1. That's why we only have 2 in the numerator there. Then for B, there's nothing to simplify. We are moving to base 5. So we just change.
Okay.
We introduce base 5 in the numerator and denominator, and then separate 50 and 7. 50 goes down. That's all. We can't simplify further because we can't write 50 as some powers. I mean, we can't simplify 50 as base 5 to some powers. No.
Okay, so the properties you've given us, so you mean we should master them or we should know them by heart?
Don't master, just know them. Yeah, you have so many things to master. So these just know them. They're easy. You can
I
master
can't
them.
get you.
Hello?
Huh? Yes, sir. But you have to master them.
You have to know them.
Oh, no.
Master.
Sir, can you just read out
Recommended.
rule number,
All right, thank you.
law number 17?
So I'm saying log y base a to the power b will be the same as 1 over b
Okay.
log y base a.
All right, thank you.
Okay. So verify law number 17. On A, we see if it works. Log 9. Log 9. Let me just put even A. Log 9A and see what we're going to get. So log 9A is the same as if we have to change for ourselves, 9, we want to change everything to base 3. So we'll have log 3A over log 9. But 9 is the same as 3 squared. So we'll write it as log 3a over 2 log 3 so that we get 3a over 2 as required. So if you're confused, what you're doing is this, because we have log 2 to the power b a, we change everything to log 2. So change the base to log 2. So what we'll have is log 2a. Hello?
Please explain A before we move B.
So b is explain.
So not 3 to the power 3.
So I'm trying to explain a using a different number. Because a came as 9, isn't it?
Yes.
That was the base. Now the law, look at the law. The law is to the power b. Now I want to put the law directly and then show that it will be like that. And then we'll get back to explaining a. So once on a, you hold them.
Sir,
You know?
is that A the power to 3 or it's I can't write that thing properly.
Is that a to the power 3?
Is it 3 to the power A now? 2 is a base, and then the base which is the power, not understanding the way you
It's a base to the power 3.
a base to the power 3 and then a.
Yes. It's log a base 2 to the power 3. So if you look at this, because of this 2, which is the base to the power something, we want to change the base to 2. So we'll have change of base, we'll have log 2a over log 2 to the power 3. But log allows us to drop the power. So we'll have log 2a over, the power will be dropped, and then we'll have log 2, meaning that the log 2 is 1. So we remain with log 2a over 3. This is the same as 1 over 3 log 2a, as stated by the law. Now, why did we choose to write 9 in terms of 3 squared? Because we are verifying the law. And the law requires that this base is to the power something. So we had to write 9 as 3 to the power 2. After having 9 as 3 to the power 2, then we applied the base as it is.
Sir. Sir.
Hello?
So on example A, that one, it's not possible that you can write it as if the way you've written it there, like 1 over 2 log A base 3.
No, that's the way it is written is the same as 1 over 2. So that the one is not visible.
Okay.
So if I have A over 2, it is the same as 1 over 2A. So don't worry. So that's the reason why we had to write 9 in that way. So we could see that the power has remained the only thing in the denominator. So I'm trying to explain the law. That is what the law means.
Sir,
You know?
so I don't understand why you used, for you to prove, you had to change the base to base 2, right? That's what you did?
Yes.
And I don't understand. You had to change everything to base 2.
We had to change, not everything, we had to change the base to base 2.
Okay, then you separated them. So
By,
it was now log
by
2A.
base changing requires separation.
Oh yeah, yes, sir. Now, how did you relate how are you relating A to B?
So now relating A to B, we are saying since A is the base 9, the only way we can write 9 to some power is by getting its square root since it's there. So we have gotten 3 the square root of 9 and written 3 as 3 to the power 2 to mean 9, so that it will look exactly as the law. Okay. In other words, so we took it as if
So B is log 9 base 2 to the power 3.
B is log
Or
A.
that's A.
It's A. Log 2 to the power 3.
Continue.
So now we took 9 first as if it was just a 9. But because we knew that 9 can have a base 3, we decided to change the base from 9 to 3. And so we had log A base 3 over log 9 base 3. We have changed the base. Then now we work out the log 3, 9, just like we did here when changing the base. Hello?
There's someone who's asking to let her in.
Hmm? I have opened the thing. So I'm sure it's just an entry.
Oh,
Sir,
okay.
Hello.
on B,
Mhm.
that the base has a power or it's log 3 base 2, then
The base has a power.
all right.
If you change the base to base 3 for B, you can't get the same answer.
So
Okay.
continue.
Sir,
Okay, let me finish A. Hello?
sir.
Mhm.
What okay, the question is, what has made us to know that we have to change this one to base 2 and the other one to change it to base 3? That's the point which I'm not understanding.
We are
Or it's
looking
just to
at
choose.
we are looking at the A in the law. So you change the base to A, which is raised to some power. That's your guide. Since the law says, look, the law says if you have log y a to the power b, it will be the same as 1 over b log a y. So what this will be telling you is that whenever you see something like this, if you can remember, look, if I have, it's not that here it's saying verify, but if I was answering a question which says solve, and I have log 5 to the power 4 a. If I remember this law, I will just say this is 1 over 4 log 5a from log, or you can just say by log a b y is equal to 1 over b log a y. I've stated the law which I've used. That's what this means. It doesn't mean I should always solve.